Okay, I think I've managed to unmute and I'm sharing my screen. Is that correct?
Yes, I can see the screen.
Okay, great. Yeah, hi, I'm Tamsin Johnson with UC Santa Barbara. I think my title is, what is my title? Associate Director for Digital Library Engineering. That's the right one. It changes sometimes. And then I have to extend my apologies to Matt and Alex, who I failed to wrangle for presentation prep. So I'm going to speak on behalf of the Surfliner team today as a whole, and particularly thank Matt and Alex for their continued contribution to the Surfliner architecture. I'd encourage either of you to chime in Q&A and provide additional perspective. Okay, so this is obviously, as Ilke has said, an extension of the conversation that we've just been having. And I'm going to start out with some slides that look familiar. What's Project Surfliner? Project Surfliner is a collaborative project of the UC San Diego and UC Santa Barbara libraries to create our next generation digital library projects. Okay, is that the same exact phrase that Chrissy used? I think things are going to diverge quickly here, though, because what this presentation is about is really about our technology decisions, and specifically it's about how those technology decisions relate to our focus on collaboration. So when we started Project Surfliner, we did have some initial ideas about how our technologies might look. There's an early slide from an internal meeting that I think Tim Marconi put together that says we definitely might use, and had a list of familiar Samvera technology. And indeed, it's strategic for us to work with the Samvera community. But one thing that's really central to the Surfliner ethos is the collaboration between the campuses. So our goal is largely to extend our team capacity by working together, and to have that make it possible for us to really successfully pursue our ambitions towards having leading edge digital library infrastructure. And our technology decisions are made with that context in place. So what I want to talk about here is how that collaboration first approach has shaped our architecture. We'll encounter some of the Surfliner products in the course of this talk. Starlight and Lark were a couple of our first products that we focused our first sprints on. You'll see familiar technologies throughout. Starlight's a Spotlight app backed by Solar in the usual way. Lark is a homegrown authority and vocabulary management system built with Valkyrie, and notably not Rails, but Sinatra over Postgres, and with a thin front end. We'll come back to that. We'll spend less time with Shoreline and Orange Empire, but Orange Empire is sort of our gloss over the idea of having IIIF services maintained in a shared way using shared infrastructure. There's not a lot of code development that goes into that, with the exception of the infrastructure as code aspect. And then there's Shoreline, which focuses on geospatial discovery. That's a Geo Blacklight product with GeoServer and Solar and the usual Blacklight stuff. Okay, and then last but not least, we've just this year come around to focusing development on the sort of core object management aspect of our project. So the staff-facing object management system is the sort of mouthful of a phrase that we use for this. that is based on Hyrax, notably running on Valkyrie and not using the Wings adapter. So there's no Fedora in this stack, but instead Postgres and S3 via Valkyrie and Shrine, and also a little Fog AWS and what have you. Okay, and here is a sketch of our broad architecture. This slide's going to come back up again, so don't worry too much about taking it in now. But I did want to give you a sort of moment to look at the brief overview before we dig in. Okay, so Surfliner is really shaped by architectural commitments that are focused on making it possible for us to continue to work together as a cross-campus collaboration. And I'm going to go over really 4 of those in particular, and sort of weave in a little bit of how they impact our practices and how they've impacted individual product decisions. First of all, building from the last talk, we have a really heavy focus on iterative planning and development. Somebody asked in the Q&A whether we adjust our sprint schedule. We do, in fact. It's usually a sort of 1 quarterly work cycle where we spend about half of our time working on Surfliner stuff, and then the individual campuses have to break to go take care of our homework. Our long-term goal is really to be able to slowly replace the individual campuses' internal needs with Surfliner products, so that when we're off cycle, we're still working on Surfliner. But in practice so far, what it's looked like is that when we break, we all have things to catch up on to keep the wheels turning at home. And what that means is that it's really important for us to be able to get appreciable work done in that time. So a lot of our decisions are focused on how do we keep ourselves on a path to delivery. Thank you for sharing the diagram in chat, Chrissy. If people look at the Slack channel, they can look at the diagram while we have slides. Okay, so what we really focus on first and foremost in keeping this iterative planning and development alive is building out the trail markers for the whole path before we lay down the rails. So we've used the metaphor laying down the tracks in talk titles in the past. And for me, it refers to both our focus on the collaborative practices. So laying down the tracks means deciding how we're going to work together before we move the train. But it also means building out the infrastructure, right? The tracks are the infrastructure in this metaphor. So before we lay them down, we have to mark the path, and the way that we do that with our technical decisions is really formative for us. So there's a couple of ways. I'll start at the macro level and then do the micro. We lay down the rails in the way that, or we lay down the trail markers in the way that we choose our products and dependencies. So in our very early days, we chose specifically to work on projects that we knew that we could ship. And part of this is about practicing things that we know that we're not doing well already. So when we started the collaboration, both campuses sort of had a history of being able to do a lot of development work, but not of converting that into production. So the trail markers are in part about, we want to know that the reason we're deciding to be in production or not is not because of technical barriers, but due to product decision making. So our early products were things that we had a pretty good handle on. Starlight as a Spotlight app was not overly complex, and Lark, which we'll dig into again in just a moment, is a really simple app that gave us a lot of leeway to work on our operational needs. So we were able to build out some of the IT ops infrastructure that we'll encounter later as part of the Lark project. And then in general, you'll note that we're building from existing infrastructure wherever we can. So that looks like Samvera, Blacklight, Valkyrie, DryRV gems. Like we make those choices. We make those choices with collaboration with this community in mind. And then likewise, we also choose our dependencies, our system dependencies and our backing services with a are these things that we're familiar with? Are we working with things that we have support from the community on? And again, for us, this is really about building those trail markers right away at the beginning of the project. Looking more, oh, I should have changed slides some time ago. Looking more at CI, looking more at the micro level, we do CI/CD. So one of the first things we do when we start a project is we build the continuous integration pipeline and we build the deployment to production into that pipeline. At first, we were kind of hedging our bets and being like, oh, well, maybe we'll do a push button prod deploy. But in reality, we felt like what we really wanted to do was get those products into production and exercise the deployment aspects of our work every time we commit. We do use cloud native infrastructure to make this possible, and there'll be a lot more about that in just a moment. And then our development processes are highly influenced by 12-factor, probably in a way that's not even visible to every one of our developers. Some of the 12-factor factors, you can find 12-factor at 12factor.net. Some of the 12-factor factors feel obvious, but some of them are actually really important. Two that are important for the CI/CD that were actually big shifts for our team. We're storing the config in the environment. So we want to vary our deployments by environment config and not by code changes. And dev prod parity. So we test the artifact that we deploy, we develop on that same artifact. And what that looks like for us is a container build that we roll out into Kubernetes. And we really want to know that we're working as closely with the same thing throughout our life cycle, so that we're testing that. This is a very nice green example of our pipelines. They're not always this green looking. Oh, and this is old. It says master. We changed that a long time ago. Okay. Second architectural point. Small services fit for purpose. So we really are using Blacklight and Hyrax and so on with an eye towards carving out their functionality into specifically defined functional areas. And our goal is really to keep our development focus tight and keep the dependencies between the products loose. So we do want individual campuses to be able to go live with one product or another independently of the others. And we also want new potential collaborators to be able to join without having to take on the whole architectural stack together. So we try and be articulate about the functional areas that individual products are working with, and we try to drive development from user requirements. That's been important on Shoreline and Comet in particular, but in the ways that that Chrissy and Jessica have touched on, we do have a nice relationship between the product side and the technical team. The most notable place where we draw a really hard line between functional areas is that we really separate management from discovery. So Starlight and Shoreline are really discovery-focused platforms. Comet and Lark are really management-focused platforms. And we want those things to be well separated so that we're not in a place where we have to make changes to user-facing functionality on the basis of an internal need or pressure. Okay, so an example of this is, an example of the maintaining clear application boundaries is the Lark project, which is sort of split itself into a API. So this is a really small, simple REST application serving out JSON LD. The modeling's done in SCOS. There's some background tasks for authority reconciliation and other kinds of background management tasks, and it's built with Valkyrie and Sinatra. And then only with that development in place did we start to think about what the front end might look like. So we did an initial spike with Vue.js and then ended up sort of leaving that behind and starting work on a Rails based thin front end with like no database backing. It's just a thin front end for the API. So that starts to feel like a little microservice-y, but most of our applications are not very microservice-y, despite our efforts to keep them loosely coupled. So Comet's big and mixes a bunch of functional areas, in part because we really wanted to adopt Hyrax in the fact that it's like the goal. Sorry, I'm distracted a little by the chat. The goal for adopting Hyrax was to meet a large number of our gathered use cases all at once. We did a big analysis and like checked off a bunch of items. This one's Hyrax, this one's Hyrax, this one's Hyrax. We can make Hyrax do this easy. And that exercise was really compelling and made us feel like we were in good hands working with this community. But Comet, to answer the QA question already, is kind of a different Hyrax application. Its storage is in S3 for the file storage. The metadata is all in Postgres, and it really took us a lot of preparation to be ready to do that. Yeah, so that's Comet. The Comet development scope feels like pretty big to us, and it's possible that what we'll do is extract bits out in the future. If there's time, I can get into that a little bit. Okay, principle number 3. We're really under pressure to be multi-cloud and multi-campus. So each campus has different infrastructure pressures. UCSB is under mandate to move as much of our workloads as possible to AWS. UCSD actually does have quite a bit of on-prem computing resources and has a desire to keep to use those rather than bill out more workloads to AWS. And similarly, the storage needs are split where the UCSD team would really like to the UCSD team would really like to keep the storage on-prem. The UCSB team, again, wants to keep it off. So the way that we address that is by building our applications cloud native for Kubernetes and deploying them there as a practice. And UCSB is using a managed Kubernetes system with in AWS. That's EKS. We'd be happy to talk with folks about how the management of that is going. UCSD actually has two separate clusters on-prem, one where they deploy production workloads and one where they deploy sort of staging and review applications. So the CB is targeting that. We do try to develop our new products for the cloud specifically. This is more 12 factors. And where we are using existing dependencies, we're trying to push them towards cloud nativity. So an example of that is opening Hyrax up to statelessness. So the little internal storage in the diagram, just this like shared storage towards the bottom left is a place where Hyrax storage state that's shared between the web app and the asynchronous workers. And we're really worried about that. So we've been working on having less of that in Hyrax. We haven't always had good luck moving our application, our dependencies towards cloud nativity. And that's always a conversation with the upstream maintainers. But we do try to keep our work focused on the sustainability of our dependencies. And some of these 12 factors start to look pretty like expected normal development processes, but we are a little bit focused on the disposability of the workloads, fast startup, graceful shutdown, and running them as independent processes. Multi-cloud does present a challenge in that using managed services is really hard. UCSB sometimes would like to just use something like an S3, and part of the selection for that has to be that that we're able to deploy that into a Kubernetes cluster. So we need the application to be configurable to run in either campus's environment. On the plus side, that insulates both campuses from lock-in. And our last principle, which I'll rush through a little bit because I'm tight on time, is always be architecting. So we are trying to adapt as we go. Those trail markers, our path to the infrastructure that we want to build, but we're always looking for places where we can make changes that make things more sustainable for us and that look towards our future scope. So you can see some places in this diagram where we have called out expected future scope. We know that we want to see content moving really seamlessly between the backend management services and the front ends. So we've started to sketch out what that might look like in the event broker and metadata API. This is an example. The event broker in particular is an example of where we, to answer Trey's question, is an example of where that multi-cloud issue is really tricky. Because on the one hand, we could use AWS's out-of-the-box queuing system, and we feel like that would work really well straightforwardly, but we really can't do that and keep our multi-cloud commitments. So that's sort of a decision to be made, where if we didn't have that commitment, we could have maybe just made it tentatively and moved and rolled forward later. And then likewise, I've actually been super interested to hear other people talking about the need for preservation. Trey says we shouldn't use RabbitMQ. I've been interested to hear people talking about the need for preservation integration. I'll remind folks that there was a grant that worked on this back under the DuraSpace auspices called One-to-Many. And we think we might implement something like the Preservation Gateway API that was defined as part of that grant. This is going to be a focus for us definitely in the late winter or early spring. I think I only just have a few minutes for questions, but I do want to open up the floor.
I think we still have time for you, Tamsin, but there is one question, additional question from Jonathan. I'm not sure whether you covered it, if you've seen it in the Q&A.
Is that Jonathan's? Yeah. So
yeah.
So yeah, Jonathan, in general, where we're using Valkyrie, we're using Postgres for the metadata store on that. And that's not necessarily a long-term commitment, but that's the way that we've rolled both the Lark configuration and really, I think really notably in some fanfare is that Comet is in fact a Hyrax app that uses Postgres for metadata. It is definitely advanced Hyrax usage at present, but it's definitely also possible if you are willing to have your hands in the Hyrax code base. And a lot of our work towards making that work is a lot of work, our work towards making that possible is happening in the Hyrax code base. So Comet's currently pointing at Hyrax main and updating a couple of times a week. Some people are typing. I'm on the edge of my seat.
As we have time, so we can. Okay.
Anna wants to know how the Starlight app knows which manifest to pull from Comet. Good question. I think that's a question that we'll be asking in earnest over the winter. Quite possibly, it's some kind of queuing or pub sub approach, and we have sort of been working internal pub sub into Hyrax in with the specific goal of being able to publish things like publish events for things like index updates, and that's increasingly baked into Hyrax, but how exactly we'll do that integration is definitely an example of always be architecting. I'm interested in the chat about RabbitMQ maintenance here.
Right. I don't see any particular question, but yeah, that's definitely going on.
Was I actually fast, okay? I thought I was pushing the time.
No, I think on our program, yeah, you had the time until 40 past, so that's why I'm just taking it a little bit slowly. Was there anything else that you would like to pick up from the Slack channel and make any other comments, or just you let me know when to?
Yeah, I'm going to use I'm going to use my a last soapbox moment to say we're super excited about running Hyrax on Valkyrie as a Valkyrie native application. We think that's really cool, and we hope that other people will join us in working on that. Like it is not done. But if you want to have a bunch of fun hacking on almost 10-year-old code base, you can join us working on opening Hyrax up to that. Trey is asking where Comet doesn't use Valkyrie. I think that I may have been, if I said Comet doesn't use Valkyrie in some places, then I may have misspoken. We're not using Valkyrie for everything. Like there is still active record stuff in Hyrax for the various database bits, but where we're writing repository objects, we're doing that with Valkyrie. Hyrax still struggles a little bit with that around collections, although that's rapidly changing thanks both to our work and Lynette's, which have been sort of happening in parallel. And I think there's some places where the file management is a little fussy, the versioning isn't very robust, and I think that's still like a Valkyrie question in general. And like how do we get adapters that have the same versioning semantics for files? But yeah, there are no places where Comet is doing what you'd think of as Hyrax's repository functions where it's not using Valkyrie. Thank you, everyone.
Thanks very much, Tamsin.